Hi, and welcome back to Physics 151, now online, at least for the next 2 weeks. I hope everybody had a good spring break and that you didn't forget everything we talked about beforehand. Just in case you did, let's review a little bit. We were talking about Newton's second law of motion as it applies to an object traveling in a circular path. Newton's second law says the net force on an object equals the object's mass times the object's acceleration. For an object traveling in a circular path, that means centripetal force equals mass times centripetal acceleration. But centripetal acceleration equals the speed of the object squared divided by the radius of the circular path that the object is traveling in. So, the net centripetal force equals mass times speed squared over the radius of the path. If we're talking about the moon as it orbits the Earth, the moon's velocity is tangent to the circular path. The centripetal force points to the center of the circular path, and that centripetal force is the force of gravity acting on the moon. Newton's law of universal gravity is written mathematically as G, which is the universal gravitational constant, times the mass of the two objects involved, in this case the Earth and the moon, for example, divided by the distance between the centers of the two objects squared. Now, what if we were to apply Newton's law of universal gravity to two people that pass in the hallway? So let's say that we have two persons. One has a mass of 60 kilograms, the other has a mass of 50 kilograms, and they pass each other in the hallway at a distance of 2 meters. Well, there would be a force of gravity acting between them, and we could calculate that, and it would be G times 60 kilograms times 50 kilograms divided by 2 meters squared. So let's put in all those numbers and see what we get for an answer. Now first let's look at the units. The universal gravitational constant G is 6.67 times 10 to the negative 11th Newton meters squared over kilograms squared. Then I've multiplied by kilograms times kilograms. So the kilograms cancel the kilograms squared. And in the denominator I have meters squared, which cancels with meters squared, and this is going to leave me the unit of newtons only, which should make sense because force has units of newtons. So when we put this in our calculator, we get 0.00000005 newtons. Or if we write this in powers of 10 notation, that's 5 times 10 to the negative 8th newtons.